Okay. Do you have one in particular that you were struggling with?
Mainly the cycle ones in the first question. I think the cycle ones were 2.66 and
Yeah, 3.66 and 3.67. Okay.
yeah.
Okay, I haven't looked at these in a couple weeks, so let me. All right. So yeah, while I'm looking at it, why don't you guys? Well, let's start by doing that, and then we'll do new stuff after. All right. So. I'm just typing it in so that when I put this, excuse me, when I put it on Blackboard, it's clear that this is different than the new stuff. All right. So we have a system with 2 kilograms of ammonia undergoing a cycle. The following processes. All right, tell you what I'll do. I'm going to, let me take a snapshot with my phone, and then I'll upload it here so we can all look at the same thing. Give me 1 second, sorry. Upload. Okay. When you guys take images from your phone, what's the best way that you guys have found to get it onto the computer?
I usually message it to myself.
Yeah, that's what I do too. I have it. I have it all kind of synchronized on accounts. So in principle, if I save it on my phone, it will show up on my computer, but it takes too long to sync. So whenever I do it, it still takes like, I don't know. Sometimes it takes like an hour. So for it to all synchronized. So I just, anyway, I was hoping there was a better way. Right. Okay, so now, okay, so here's the problem, Gabe. Is this the one you were talking about?
That's it, yeah.
All right, let's just work our way through this one. So we have a system. I'm just going to kind of highlight things that I notice as I read it and kind of see how I work through them here. So I notice I have 2 kilograms. Anybody? I got to do this. There's a cycle. Okay, that's fine. I have, so okay, let's just kind of, okay, it even asked for the sketches, but even if they didn't ask, I would do the same thing. Okay, and P, V, and T, V, saturation curve, something like that. All right, 2 kilograms. So from 1 to 2, I have constant volume, 10 bar, and a quality. Okay, so that at state 1. So I know at state 1, I have a pressure 1 and a quality 1 are known. At state 2, I know that the volume is constant. So once I have these numbers, I know that once I need to find, so I'm going to need to find, all right, so let me make a grocery list here. Need to get a specific volume at state 1, because then that's going to remain constant. At state 2, I'll know that specific volume 2 is the specific volume of state 1. So that's one fact. And I know it's also saturated vapor. So that's two facts for state 2. And for state 3, I know it's the temperature is constant. Leave. Go to your room. Go to your room. At state 3, I know that the temperature at state 3 is equal to the temperature at state 2. So I'm going to need to get temperature at state 2. And once I find that, I know it's the same for state 3. And I know that from 3 back to 1 is constant pressure. So I also know that pressure at state 3 is equal to pressure at state 1. Okay, so far, does everyone give me a thumbs up if you follow my logic there? I kind of feel out what I know. Sorry. All right. Okay, so show me, can you give me a thumbs up if you guys see how I got that far? I'm not seeing any thumbs up. Oh, there's Gabe. All right. That's weird. So bizarre. Okay, Zoom's acting funny for me. Anyways, all right. Hopefully you guys are following that. All right, so now that's fine. And what they want me to find, so I have to sketch it, and then they want me to evaluate the net work and heat transfer of the process, all in kilojoules. That's fine. All right, so let's kind of work through this. P1, and I know that's in a mixed state. So I know that state 1, I'm going to put a red dot there. I know that state 1 is here. And this will be at pressure P1. It's in a mixed state. And then I know from 1 to 2, it's isochoric. And so from 1 to 2, it's isochoric. And 2 is saturated vapor. So I know it's got to move upwards. So I know it's got to go upwards from 1 to 2. So state 2's got to be here, just like state 1, state 2. And then I know from 2 to 3, it is constant temperature. Oh, I'm sorry. I should have been plotting all these same points here. So the initial points here, then state 1, state 2. And I know that it's isochoric. And then I know state 3, from 2 to 3 is constant temperature. So that means I move this way on this graph. And at constant temperature on a PV diagram, I know that that generally kind of goes down like a hyperbolic sort of thing. And I go down all the way so that it's at state 3 is at the same pressure as state 1. So it's got to go down to here. All right. And then, so that'd be state 3, and now I need to connect them up. So I know over here, 2 to 3 was at constant temperature. And then isotherm looks something like that. And then from 3 back to 1 and is an isobar. So that's going to be horizontal here. And an isobar on a TV diagram, it looks like this. It looks like roughly linear, not when you're in the gas part. And then it's going to have a bend in it. It'll be horizontal in the mixed state. Ugh, that's terrible. So it has like a kink in it here. Let me kind of zoom in here. It should, if I zoom in, it should be something like, here's the saturation curve. Here's state 3. Here's state 1. And then the curve from 3 to 1 should look something like this. It should be kind of like, oh, that's terrible. Up. And then it should be constant over. So it should go like that. So it should be, I managed to make it worse. That takes real skill. All right. So it should be in the mixed state. An isotherm is also an isobar. So it should be horizontal inside the mixed state. And then after you cross the saturation curve, it's going to kick up to state 3. So it should be horizontal and then kick up, roughly linear, because it's an isobar on a TV diagram. Okay, so I'm just trying to enlarge this little region here. Right there. Okay, give me a thumbs up if that makes sense to you. Gabe says yes. For some reason, I'm not seeing many people here. Is anyone else? Brian, can you hear me still?
Yeah,
Okay, all right. So give me a thumbs up if that makes sense, how I'm
I
sketching.
did.
Okay. I'm not, all right. I can't see anything popping up on
I
the,
just did it again. You see it?
no.
Yeah, like
That's
everybody
there.
did.
Are you kidding? The only one I see is Sydney right now. All right. Now Michael did. I don't know. I don't know if there's if it's a time delay or something. That's weird. You guys can all see it. All right. We may have to do it verbally then, because I don't see it at all. All right. Okay, so that's the cycle. And then look at the problem again. So then I want the heat and work. All right, well, let's go just work our way through this. Okay, I've got these kind of numbers. From 1 to 2, I know it is constant volume. So let's just make a list here. Let me change back to black here. From 1 to 2, constant volume. Work from 1 to 2. What is that? Just call it out.
0.
And how do you know that?
What was it? When volume is constant, work is 0.
Yep, it's that simple. And so therefore, if the work is from 1 to 2 is 0, then the heat from 1 to 2 is just going to be U2 minus U1. Make sure to do 2 minus 1. All right, so on my list of things that I want, I need U. Actually, I'm going to group them according to this. I need U1 and I'm going to need U2. I'm putting all the things at state 1 together and all the things at state 2 together. All right. Now, then to get the work from, let's see here, from, okay, so I'm going to need work from 2 to 3 and heat from 2 to 3. Let's see what we can say about that. Okay, I know that the temperature is constant from 2 to 3. Sorry. Constant temperature to P3, which equals P1. All right. So I know the temperature is constant. And let's see. Oh, and they give me the heat. There you go. That's what I need. They give me the total heat. And I probably would divide by the mass so that I can turn this into a little lowercase q, 2, 3. And then because I know the heat added, then because I know that, I can figure out the work from 2 to 3. The work from 2 to 3, I'm just going to get from the change in internal energy. So I'm going to say that the work from 2 to 3 is the heat from 2 to 3 minus delta U. So that means I need to look up, I've already listed U2, but I'm also going to need U3. Right? And then that's going to feature, that'll give me the work from 2 to 3. And now I need to go from 3 back to 1 at constant pressure. So I know the work from 3 to 1 and the heat from 3 to 1. Well, at constant pressure, I know the heat from 3 to 1 is, let's see, what's going to be the easiest way here? So I have a couple options here at constant pressure. I can either use enthalpies or P delta V. Since I know the pressure, and at this point, I would already know specific volume for state 1, I might as well say that the work from 3 to 1 is P delta V from 3 to 1. And so to do that, I'm going to need to look up specific volume for state 3. So somebody rephrase that. Why am I using this form instead of saying, in the last example we did, we used the change in enthalpy minus the change in internal energy to get work. Why am I saying use P delta V this time?
Because there's constant pressure.
Well, the other one is constant pressure too, but you can use they're equal. Why is this the smart way to do it for this problem?
We have given values for it already.
Yeah, you already know the pressure, and to work out state 1, you need to figure out, or to go from 1 to 2, you had to find the specific volume anyway for state 1. So you've already done, 2 of the 3 numbers are already known at this point. So you might as well do that. Okay. And then we need the heat from 3 to 1. That's going to be, the heat's going to be delta U. 3 to 1. We already know those numbers at this point. They're already in our grocery list. And then I need to add the work, which at this point we would already know. Okay. So at this point, I've kind of worked my way through and I've constructed my grocery list. So once I get all these numbers, I can go back to this kind of list of formulas and work out everything. Let me stop there. So let me stop there. And I want you to, if you're not following this logic, before we dive into numbers, let's make sure we all understand the logic of this, because once we start talking about numbers, it's just random digits and decimals and stuff like that. So the logic is the important thing. Nobody's saying anything. Are you guys being shy, or it's all just that easy? Nobody's willing to say. Question? Who's that? Somebody say something.
It's like once you explain it, it's not difficult. But when you're on your own, I don't know. It's just like I just get confused in my head. I can't work it all the way through.
Okay.
I don't.
The only way to make it better is just to solve problem after problem. So here's what I would suggest. So like I said last time, On Wednesday, I want to have the exam in class. Here's what we're going to do. I'm kind of making a on the fly decision. I think on Monday, we're going to work these through. We're going to break in person in groups. And I want you guys to do, we're going to do have a problem solving day in person. Because I think that's the part of this whole online thing that's really missing is the practice in person. But I think it really comes down to solving problems, problem after problem after problem after problem. What I can suggest is, because I know you don't have any other classes with homework, so over the weekend, why don't you work? I would suggest working through all the examples of cycles in the book that are there. Make sure you can do all the examples that they do, because they give you their logic and you can kind of see it. And then on Monday, we'll practice in class. I think we'll just make it a practice day where we practice solving problems. And then hopefully that'll get everyone ready. For the rest of today, so for this one though, why don't we finish this one together? If you weren't there on Wednesday, what we did is we broke into groups and that seemed to help people. So tell you what, why don't you guys maybe take a screenshot of this stuff? And then I'm going to break you guys into 3 groups. And I want you guys to try to solve the problems from there. Okay. So you'll need to turn on your videos if you can, once I put you guys into groups. So while I'm doing that, I want you guys to so take a screenshot, and then I want you to work in groups. Well, that didn't work. What the heck? Breakout rooms. All right, I'm gonna have to stop screen sharing, I think, to do this. So make sure you take an image with your phone if you've got it. All right, so I'm gonna stop share. Oh, there you go. All right. Let's create 3 breakout rooms. Create. All right. I'm going to put 1, 2 there. So, and then room 3. All right. So you guys should be as soon. Open all rooms.
What time is it?
Go, you're a smart kid. Go look at the.
Alexa, what time is it?
It's 10:27 a.m.
All right. So were you guys able to take like a screenshot or camera or something?
Yeah.
Okay. So go ahead and start working through those things then. Okay. All right. Oh. Where's Sydney? There she is. All right, Sydney, there you are. Were you able to were one of you able to take a screenshot of the work I had done? Yeah, okay. So, so what we did last time was have people use the whiteboard feature. So you guys should be able to use the whiteboard feature. And so if you go to screen share, there should be a whiteboard option on Zoom, and you can draw and kind of write in numbers as you do it. Okay. Do you think you know how to get started on it, on the problem?
Yes.
Okay. Sydney, how are you feeling? Yeah.
But how I do the whiteboard feature? I can't see it.
Can you go to screen share?
Yeah. Oh yeah, I saw it now.
Okay. Yep. All right. Okay, Sydney, you okay? All right.
They do is they just multiply the value by quality. So I don't know.
Yeah, I think there's a formula for that. Let me grab my book.
Is Zach in here?
Mhm.
Okay. It's so weird. So for some reason, I'm not seeing everyone who's around. I don't know what's going on there.
That's goofy.
So Sean, why can't you just multiply the one value by the quality? Why do you gotta like do the two-step? It seems like a weighted average or something.
It is. Well, but remember, Zach, when it's in the mixed state, the individual droplets are either gas or liquid, and it's a mix.
Yeah.
And so the liquid part is all saturated liquid, and the vapor part's all saturated vapor. So when you want to work out like the specific volume,
Oh,
well, it's so none of the droplets live at that place. They either live on one side or the other. And so you're just trying to, and so you're just trying to say, well, it's a mix of each. And so you have to average the numbers from each. That being said, when you're really close to one end or the other, well, then it's pretty much just going to be the numbers of the saturated values. But you really, if you've got a quality, you should do the averaging.
okay.
That's literally what it is, a weighted average. Yep. Remember, you can use that whiteboard feature. You should be able to go to screen share and hit whiteboard, and you can write the numbers down to make sure everybody's getting the same things.
So we need to find V1 and U1 at 10 bar. Did you take, Sean, should I take all the saturated liquids and the saturated vapors off the table because we're in the middle at 0.6?
Yes, you're going to need.
Yeah.
You're going to need, since you want specific volume and internal energy, right? So you want to do, you're going to need the saturated liquid and saturated vapor numbers for both specific volume and internal energy. And you have to use
Okay,
the
I did that right.
Yeah, and you're going to need to get the quality to use that to get your everything. Mm-hmm.
All right, so that means I got the first part right.
Can
Second's where I got
Can you
stuck.
write it on the whiteboard so we can see what you
Hold
did?
on 1 second. I can mirror my iPad.
There you go.
Come on. Okay, that was weird. Come on.
Zoom, I've been having trouble with Zoom the last couple of times, so I don't know if there's an
Can you
update.
see that?
I can see it.
Okay. Okay, there's the graphs.
Yeah.
So I got those right. I'll show you the work. I got the first part correct, I think, if I use the right value.
How did you find the specific volume, and how did you find the internal energy?
The table. I went to table A14 and then went to 10 bar.
Right, and so you needed to look up the saturated liquid and saturated vapor numbers to do that,
Yeah,
right?
yeah.
Yeah.
And then after I got those are the actual values, then when I actually used it to find them, I multiplied it by that quality formula to
Mhm.
find them inside the saturation curve.
Yep, that's right.
Okay. And then that's where I got. And then, I mean, I started working on your homework after doing a ton of other homework. So my brain was already fried. So I just kind of lost my train of thought and I didn't know where to go after that to find 2 to 3.
Do you have other classes?
Science.
I know, right?
Less than 2 minutes.
Okay, so then what do you know about state? So to go from 1 to 2, you know that state 2 is saturated
On the saturated vapor line.
vapor, and you know the specific volume is constant. So now you need to go to the table and figure out where that would put you on the table.
Should I go to the superheated vapor table then?
Well,
Yeah.
you know it's saturated vapor,
Okay,
so you
so
want to
now,
be
yeah.
in the saturated table.
Gotcha. You don't know pressure, and you don't know temperature, but you know.
Specific volume.
Wait, how do I know specific volume again?
Well, you should have used quality at state 1 to find the specific volume.
Okay, I see what you're saying. 'Cause, yeah, it's going straight up. That's right.
Yep.
Yeah.
All right, so you work on that. I'm getting a request for help, so I'm gonna go there.
Okay.
Wants us to do like the whole thing,
Yeah, everything. Come on,
everything.
everything.
Okay.
Where are you guys?
So I already did this, so I'm looking at my old
Oh, okay,
homework.
great. That's fine.
Oh, okay. I did phase 1 to 2 last night, but I couldn't do it at 2 to 3, so I
2 to 3.
no. I mean, I can do it now because you tell me how to do it, because you told me how to do it. So
Okay. What was the thing that was giving you trouble from 2 to 3 last night?
I was sleepy and I couldn't think about anything.
That's that's an important thing. If you notice that, that's an important thing to know about yourself. Like for me, when I was a student, I could spend 30 minutes in the morning or 2 hours in the evening because I knew that I made many more mistakes in the evening. So if you know that, then yeah. Okay. All right. So you feel like you can do this then? Sydney,
Yeah.
Can you do this?
Yeah.
Awesome. All right. I'm going to go to another group and I'll try to circle back.
Okay. Stefan.
How's it going, guys?
We're having trouble finding the internal energy for 2.
For 2. Okay. So did you find the specific volume for state 1?
Yes.
And then that's supposed to be the same number as the specific volume for state 2, and it's saturated vapor.
So you can just go to the table and see where it's close.
Yeah, and you might have to interpolate, or if it's really close, I just run with it. So what specific volume did you find for state 1?
0.0778.
0.0778.
Yeah.
What liquid is this?
Yeah.
Is it ammonia?
Yep.
Yeah.
Okay, so I'm looking at ammonia. Oh, there we go. Okay. Specific volume. They give me one that is 0.0717, and the other one is 0.0808, something like that.
Mm-hmm.
Yeah.
And I look at those and I say, man, I'm closer to the 0.08. I'm in the middle. I really should interpolate. and that frustrates me, but I really should. So I'm somewhere between 16 and 18 bar, right?
Mm-hmm.
And I'm a little closer to 16. So I would do an interpolation at this point. So can you guys see my whiteboard?
Yep.
Yeah.
Okay. So I would say, all right, so hold on, what number do I want? Actually, do I need the pressure number? Do I need the pressure for this one or
Nope.
no? Okay, so then I don't worry about interpolate. I don't interpolate to find pressure. What number do I need to pull out of this?
Internal energy.
Internal energy, right. So what I'm going to say is what I know, so what I want is the internal energy at state 2, and I know the specific volume at state 2, right?
Mm-hmm.
So what I'm going to use is I'm going to say the internal energy at state at 16 bar. And I know, so these are things, sorry, put in the wrong spot. I know internal energy at 16. I know specific volume for saturated vapor at 16. And I know internal energy at 18 and specific volume at 18. And I'm going to use a point slope formula to say U at state 2 equals U at state, let's just use 16, plus, I have to get the slope, which is going to be U, let's do 18 minus U 16 over specific volume 18 minus specific volume 16 times the specific volume I know minus, and since I chose 16 here, I have to use specific volume 16 here. Okay, that's Alex. Does that make sense where I'm getting, do you see how I'm getting that?
Yeah.
This is so I'm just interpolating. Now I'm just going to read them off the table. So this number is, I got to be careful, get the right column. So at 16, I see 1340.97.
Mm-hmm.
All right. And then my slope is going to be U18. That's going to be 1341.88 minus 1340.97 divided by the change in specific volume, which is 0.0717 minus 0.0808 times specific volume at state 2. You guys you had that number. I don't know that number. What was the specific volume for state 2 in the problem? You calculated it.
0.0778.
0.0778
78. Yeah.
minus this number, which I just looked up to be 0.0808. Whew. And I don't have a calculator here, so you got to calculate that.
1341.12.
0.12. All right. It's a lot of work for about the same number. Anyway. All right. So there you go. Now we can sleep well because we know it's right. All right. So that's the internal energy for state 2. And give me a second here. I've kind of lost track of what they need to do. Internal energy for state 2. And is there anything else I needed to pull out from state 2?
We need temperature at 2.
Temperature at state 2. I gotta do the same thing. Well, crap. Here's the thing. Let's eyeball it. Let's cheat a little bit. All right, so we know 7.1, 7.8. Isn't it going to be about 3/4 of the way between the two? Is that about right? Am I eyeballing that? Or 80% between them? I think it's going to come out to be like it's going to come out to be like 41 and a fraction or 42 degrees. It's right around there. If not, we should interpolate, but I think that's what it's going to come out to be. All right, well, we can just do it. So if I can go back, do you have these numbers?
Yeah.
All right, we can get. So we know, we want T2, we know specific volume 2, and then we can look, we know the temperature at 16, you know, the temperature at 18, we know specific volume at 16, specific volume at 18. So I can say T2 is going to be temperature at 16 plus I need the slope. So temperature 18 minus temperature 16 over specific volume 18 minus specific volume 16. I write it all down each time because if I just start typing numbers in, I get confused as to what I've done. I just don't want to second guess myself. So I just use that. And then I do the known specific volume at state 2 minus specific volume at state 16. And I have to use 16 because I used that over here. So I'm just going to plug in numbers here. Temperature state 1 was, temperature at state 16 is 40.03, 41.03, sorry, plus, and this would be 45.38 minus 41.03 divided by the same numbers we had before. 0.0717 minus 0.0808 times 0.0778, I think you told me, minus 0.0808. They get all those numbers right?
Mm-hmm.
All right. I'm guessing you get something pretty close to 42, maybe a little bit less.
42.46.
Okay. All right. Well, it's good we did it. I would have rounded the wrong way. So we get T2. It's 42.46%. Awesome. Okay. So that's temperature at state 2. We know the internal energy at state 2. And how do I go from 2 to 3? What did the problem tell me? Tell me the temperature was constant, right?
Mm-hmm.
So at state 3, I know it is, what do I know it's about state 3? At state 3, I know it is, what phase is it?
Is it vapor?
It's vapor. So at state 3, I know it's vapor. So 3, I know the temperature at state 3 is 42 point whatever, blah, blah, blah. I know it's vapor. And I know that the pressure at 3 is equal to the pressure at 1. Right, because because you have to make it into a cycle. So it has to be level with the pressure at state 3. So now I go to the superheated vapor table. And what pressure was that? Is that 10 bar?
Yeah.
So thankfully, it should be one that they give me. All right. At 10 bar, okay, that's in the tables. That's from table A15. And the temperature is 42. So I'm in between. So I'm going to have to interpolate in between. And I want U3, right? Because I know everything else. I want U3. And I know from the table, U at 40 degrees. And I know U at 50 degrees. And I know the the two temperatures, and I know the temperature 3. Okay, so then I want to kind of use that, and I want to say U at state 3 is going to be U at state 40 at 40 degrees plus the slope, U50 minus U40 divide. I'm interpolating using temperature, so that's going to be 50 minus 40 degrees, and then I'm going to use the temperature at state 3 minus temperature at state 40 or 40 degrees, which is just 40 degrees. And I just start dropping numbers in there and you make sure you're in the right column. Okay, so that's going to be, what do you get for U at state at 40 degrees? 10 bar.
1369.52.
Good. And what do you get for U50?
1391.07.
Zach keeps asking for help. All right, all right. You guys see how to pull it all together from here?
Mm-hmm.
And now you have all the U's, you have all the volume. Oh, you still have to find the volume at state 3. So you're gonna have to do something similar to this, okay?
Okay.
All right, I'm gonna go over to the other group. I will be pulling you guys together here in a minute. Actually, I'm gonna pull you guys all together now. So go ahead and finish this, but I'm gonna pull everyone out of the groups because we're about out of time.
Okay.
All right. Rooms and close rooms. right. Is
Oh, and you have the white bar again.
All right. Try again. Any better?
Nope.
All right, we'll try. I will try to do it using the whiteboard through Zoom. You know, that's coming. You see my whiteboard space now? You can see that.
Yeah.
Okay. I don't like using their whiteboard because it's not as I don't know, it's not as easy to edit things. You can't drag and drop stuff, but whatever. Okay, so I can't see everybody again. So how many groups were able to find specific volume for state one? Just call out. Actually, call out if you couldn't. That's easier. Okay, so you should use quality to do that. Same thing for the internal energy at state one. You have to use a quality to do that. All right. What about state two? So for state two, you needed to use that specific volume and look at the saturated curve, saturated table. And the problem you have is that specific volume is not one of the numbers in the table. So you had to interpolate, and you had to interpolate between 16 and 18 bar. Okay, so you should have had to, the specific volume you would have had should have been, I think, 40, no, should have been 0.078 something. Is that the specific volume everyone found for state one? 0.078 something?
Yeah.
Gabe, is that what you found for state one?
I didn't do the quality thing to find that. I only did it for internal energy.
Oh, you
We didn't even get to 2 to 3. We just got to 1 to 2. We were
Okay,
just double
so
checking that.
we're kind of running out of time. Let me kind of sketch the steps you're going to have to do. So here's the fun for you. All right. To get specific volume at state one, you need to use quality. Get internal energy for state one, you're going to use quality. Then to get the internal energy for state two, you're going to interpolate between between 16 and 18 bar. And similarly, you're going to, again, to get the temperature for state two, you're going to interpolate between 16 and 18 bar. Then you're going to use that temperature because it's from 2 to 3 is constant temperature. So you're going to use that temperature and it's going to be superheated. So that means you're going to, and it's not going to be in the table. So then to get the internal energy for state 3, you're going to have to interpolate between, I think it's between 40 degrees Celsius and 50 degrees Celsius. I think what you actually get for T2, I'll go ahead and give you a hint. I just did it with Alex and Michael. I think it was with them. I think it comes out to be like 40, is it 41? No, it's 42 point something.
42.46.
46 degrees Celsius. That's what they were getting. I didn't run the numbers, but that's, I think, well, I kind of walked them through it. So I think that's what you're going to get. So which means you're going to have to interpolate in the superheated table between these to get this, to get the internal energy at state 3. So at that point, you'll have U1, U2, U3. Oh, and you're going to have to do the same thing to get the specific volume at state 3, because that was also on our grocery list. So that was right. So you're going to have 4 interpolations and 2 qualities to get all these numbers. Right. But once you have all the internal energies and the specific volume at state 1 and state 3, then you can go through and just pull it all together to get all the heats to get, and that gives you, and that'll give you, sorry, that gives you the specific amount of heat and the specific work, and you have to multiply by, I think 2 kilograms it was, to get the actual work and heat. So, and then remember to multiply by mass to get capital W and capital Q. Don't forget that. Personally, I always forget that. If I screw this up, that's what I do. Woo, lots of fun left. Okay, are there questions? So again, I guess take a screenshot of this. So you kind of remember, these are the little bits of fun left to do.
So is this still going to be due tonight, or is this going to be due Monday now?
No, you can do this. You can do
Well,
this.
no, I mean the homework in general, because you said you wanted us to work on it on Monday.
No, we're going to do other, we're going to practice problems, but I want you to do this tonight. But we're going to do, I want you to do it tonight, but we're going to do, Monday's going to be a practice day, but I'm going to have other problems for you guys to work on. Yep.
What's the interpolation formula?
Just point slope formula for a line. So, so what I always do to interpolate, can I change screens here? Can I? Okay. Is everybody okay? Take a screenshot, make sure you've got it. Okay. So what I use is I identify what I want and then what property I know. So like in that example, I would, let's say this one, all right, to get U3, for example, where the temperature is 42 and change. Okay. So I want U3 and I know T3. And then I look in the table and I will also know the internal energy at 40 degrees and internal energy at 50 degrees. So what I do is I say, okay, the internal energy I want equals, and it's going to be, I pick a point, 40 plus the slope times what I know, T3 minus, and since I use the value of temperature from the point, 40 degrees. And I have to use 40 because I already use 40 into internal energy, so I have to use the same point there. And then the formula for slope is just going to be, so I'm just going to use these things to get the slope. So in this case, it's going to be U50 minus U40 divided by 50 minus 40 times T3 minus 40. Yep. And then so that's how you're going to do. At this point, by the time you get to this point, you're either going to just read these numbers out of the table, and then T3 you're going to have already calculated. So you just read them off and plug them in. Yep. Just a comment on the test. Obviously, even after you draw the diagram, you kind of make your grocery list of things you want, map out how you're going to solve the problem, you still have 30 minutes of calculator. I am cognizant of that. And so on a test, obviously, I'm not going to choose a problem where there might be one interpolation. We're not going to have 6 interpolations to do in the middle of a problem just because there's not time, right? Because otherwise, to work one of these out takes, you know, if it takes an hour, well, that's half the test time for one problem, right? So and it's not, I mean, I'm a little bit faster at this than you guys are because I'm more, I have maybe a slightly better picture of what to do. But bottom line is there's a lot of grunt work and there's no shortchanging that. And so it takes me, and maybe this one takes, if it takes you an hour, maybe it takes me half an hour. So I know that it just takes time and that's just how it is. I've got an assistant today. So on the test, I will not be putting such a big problem. Okay. All right. Are there questions before I let you guys go on how to pull this together? You want me to flash the previous page one last time? Let me do that. That kind of is your roadmap through this problem. That plus the other thing. The other cycle, if I remember right, is very comparable to this. I think one of them is metric, one of them is barbaric units. So basically the same idea. Okay. I'm in overtime here. So I will let you guys go, try to get them done. And then on Monday, we're going to do more practice problems. I just got to practice. All right. See ya.